This recording is for showing how to measure and then what to do with the numbers. So let's say we were to measure, for example here, 78 grams for the teddy bear and 31 grams for this toy car and 8 grams, 8.0 grams for the rod. And let's say that the rod is to the right hand side by 2.5 centimeters and the toy car suspended to the right hand side by 10.8 centimeters from its suspension, which is the string, to the pivot, which is the string that holds the rod, and then the teddy bear is to the left by negative 4.6 centimeters. Remember, when you measure to the left, you have to measure negative numbers. Okay. And this is, of course, an example. I just completely make up the numbers. Well, just for an example here. So I made them up out of the blue. So let's go over and see what we're going to do with the numbers. Okay. So here I'm going to put in M1. That was 78 grams, and then M2 I put in as 31 grams, and M3 as 8.0 grams, and X1 that was a negative 4.6 centimeters. Notice I supplied the negative already here because we know that one of the two numbers, the one that's on the left, has to be negative anyway. And then I have a positive 10.8 centimeters here. And then for the rod itself, well, here I don't know if the middle of the rod is to the left or the right. That's why I didn't write the negative or a plus here. You would have to do that. So in this case, it was a plus 2.5 centimeters. If you remember the other, the drawing on the right hand side, that X6 I believe it was, would be actually ending up with a negative in front. Okay, so here this is how you plug in the numbers. Okay, and then they go in here. It's M1, which is 78 grams, times negative 4.6 centimeters. I'm going to leave out the units. We know this is gram times centimeters in the numerator and grams in the denominator, which means that the grams will cancel, and we just have centimeters left at the end. Okay, so 78 times negative 4.6, and then we have 31 times 10.8, and then we have 8.0 times 2.5, and in the denominator we have the total mass here, so 78 plus 31 plus 8.0. And we're going to do the calculation in just a moment, but what we would expect here is, what we have to expect is that the center of gravity comes out to be 0, because it has to coincide with where the pivot is, and since we defined our pivot as the 0 point, our result has to come up with 0 respectively, since it's a measurement very close to 0. So let's go over to a calculator and calculate it there. Okay, this can be done, one thing at a time. 78 times negative 4.6 and so on. I like to do it all at once, because then I can easily go back and fix something that I had that went wrong without having to go through 4 steps or so, but just fix one thing and do one big step here. So 31 times 10.8 and so on. And I meant to hit the decimal point. I missed it. I'm going to leave it the way it is right now. And by that we will expect that I will have a mistake here, and we'll see what happens. So 78 plus 31 plus 8.0. Make sure that you put parentheses around denominator and numerator. Hit enter. I should come up with 0. Obviously I don't, which means I have some mistake there. In fact, my result is so bad I must have made a huge mistake. And I said that earlier, that was accidentally. I left out that period, and here's why it comes in convenient. When you type in everything at once, I just go right there where I noticed that's where I left out the period, the decimal point. Hit enter, and I come up with negative 0.034 centimeters. I could call this negative 0.034 or negative 0.03 centimeters. So that would be my result right here. 0.034 centimeters. I wouldn't have to make this any more accurate. In fact, I could almost truncate here. I could almost make the point of, I could almost truncate it right there. I'll leave the 3.4 there. I could almost write 0.0 centimeters because I didn't measure any more accurately than a tenth of a centimeter. In fact, the other numbers are rounded to the closest centimeter. So the negative really here doesn't mean anything in the front of this. This just means that my calculated center of gravity is to the left of the pivot point. If it was a positive, then it would be to the right. It's supposed to coincide with the pivot point anyway, and overall that means that I'm really close to the pivot point with my center of gravity, and that was the idea, to calculate the center of gravity, the torques which are acting on the objects as they're pulling down on different parts of the mobile, and calculating center of gravity.